Okay, now we've finished with the vectors questions. We're going to move on to question 6, the first of the proof questions. So if we have a look at this, we're asked to prove that, so as soon as we see the word prove, this requires a little bit of mathematical rigour. The square of any single digit natural number does not end in a 3. So a natural number is any counting number, so this starts with 1, 2, 3, 4. A single digit means we're going to stop at 9. Because there's very obviously a finite number of things, and we know what they are, it's the numbers 1 to 9, we're going to do this question by exhaustion. So we're going to start off having a look at 1. 1, 2, 3, 4, 5, n equals 6, 7, 8, 9. We don't need to test 10, because that is a double digit natural number, and we're told to specify single digit, and we don't need to test 0, because 0 isn't a natural number. All we're going to do now is square these, so we're going to get 1, 4, 9, 16, 25, 36, 49, 64, 81. So we can see from here that none of these end in a 3. Now we're done, but because this is a proof, we need to actually say why we are finished with this. So I've just written out by exhaustion. I'm telling the person reading it why this has proved it. It's a proof by exhaustion. No square number ends in a 3. And we were able to do this because we were given a finite number of things to count or to check. The food for thought on here is this always true? If we think about multiplying two numbers together, using a grid method maybe, the unit always comes from multiplying the two units together. So if we, for instance, what about 63? So the unit of this is going to come from the 3 times 3. So this is going to give us a 9. So in general, any number squared has got to end with either a 1, a 4, 9, a 6 or a 5. Because its unit column will always come from one of these two. So it's always true. No square number ends in a 3. That wasn't what we were asked to do. We're only asked to prove single digit. So we can stop as soon as we've done all of our single digits.